Well, why don't we change the type of equation we've always looked at for the past 2 semesters called chemical equation into something called a nuclear equation. In a sense, I think they're even a little bit more easy if as long as you don't have to memorize a bunch of bizarre particles. You have to take a course in modern nuclear physics. There's a junk load of particles. It's just like, oh my gosh, can't remember that. So the good thing is you don't have to remember very much in our chemistry course, but this a few that are not nice to remember. The alpha particle is the helium nucleus, the beta particle is the electron, the gamma ray is not a particle, it has no mass. It simply is an electromagnetic wave of super high frequency and energy. Don't remember the positron at all, but you probably remember this notation, nuclear notation from way back long ago in chapter 3 where we talked about the Z number, the atomic number, is the number of protons, which determines the element. So if I had 6 protons, I'd look up element 6 on the periodic table, and it's carbon. But the total number of nucleons, which is 6 plus 6, or 6 plus 7, or 6 plus 8 for varying isotopes of carbon, gives us the total mass number up on top. In this topic of this thing is balancing these nuclear equations, making sure the left hand of the arrow before and the right hand of the arrow, I could call them reactants and products, but that implies chemistry. Sometimes they're called parents and daughters. I don't know. Whatever. Seriously, they are sometimes. Anyway, let's look at a few. Again, I say the important. I don't know how important this is. It's not very important for our final, but if you knew the beta particle is the electron, the alpha particle is the helium nucleus, and the gamma ray really doesn't have numbers because there's no mass to it. But let's see, what's element 30? I don't know. Oh, it's like zinc, isn't it? Element 30, zinc? Get my glasses on here, I can't even see. I think that's zinc. 30? Zinc. 30, I swear 30 is zinc. And this would be zinc with 40 neutrons, because 70 minus 30 is 40. How about choice D here, I believe? Which nuclide slash ion is described by, let's see, oh, what's element 24? It's chromium something, isn't it? And then subtract 52 minus 24 is 28. 28 neutrons. If it has 2 less electrons than protons, that gives it the 2 plus electrical charge. So if I had 24 minus 2 electrons to make it a 2 plus charge, it would be 22 electrons. So 22 electrons, 24 protons, 20 electrons, yeah, chromium. Choice C right there. What's that nucleus? 1, 2, 3, 4, 5 positive protons, looks like boron, and 1, 2, 3, 4 plus 5 is 9. So how about 5 and 9? Yeah, 5 protons, 9 particles altogether. Go with choice E. In these balancing the nuclear equations, we're just looking at the nuclear particles, and the nuclear particles sort of have to sum together on to equate, to be equal on both sides. So 90 plus 2 is 92, and 234 plus 4 is 238. So if I didn't know any one of these, I could probably figure out the numbers. Then to figure out the symbol, thorium or helium or uranium, excuse me, just look up the number of protons. 92 is uranium, 2 is helium, although you should know that's alpha particle. 90 is thorium. 91 plus what number gives you 90? In some cases it's a negative number. This negative 1 means it's not really a nucleon at all. The electron doesn't belong in the nucleus, so that's a 0 there as well. So anyways, that's the beta particle. The gamma rays have zeros, so those could be written in there, 2 gamma rays given off, but the masses are unaffected. This is the positron, bizarro, anti-mass. 1 plus 10 is 11, and 0 plus 2, 0 plus 22 is 22. So this side 22, 22, and this side's 11 protons in the nuclei altogether. Well, it's 11 protons in this nuclei, but this one must add together to give that, or we could say that this 11 decays to give off one positron. Whoa, that's weird. So it's weird to think about the nuclear changes and what is the result that comes out of such transmutation or such change of the nucleus. Here's mercury 80, capturing or gaining a negative electron, a beta particle. 80 plus negative 1 is 79, and 201 plus 0 is 201. You wouldn't necessarily know it gave off a gamma ray, but you know there's got to be some energy associated with it. You could say otherwise, if it's endothermic, then you have to add energy into it, but most changes are exothermic anyway. Whoa, there's a whole bunch of confusion. I'll let you look at those if you feel like it. But again, I don't even think you need to remember the neutron. Certainly not the positron. This is just with a 1 here and 1 here. I could call that a hydrogen nucleus, which is just a proton. I think I went over this series of decays in a previous video. Should I go over it again? If I go alpha, beta, beta, alpha, 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 beta, beta, alpha, beta, beta, alpha, in that order, I get down from uranium-238 to lead-206. Or I could actually go in any order I wanted to, but that seems to be the natural state of affairs, as uranium naturally decays into lead. There's still some uranium in the Earth's crust left over from when the Earth first formed, but there's quite a bit more lead. Each of these half-lives, each of these decay processes are statistical and probabilistic in nature, and they take a certain amount of time, sometimes a long time. But if I wanted to sort of equate the uranium decay with helium and beta particles, I could say 6 times 4 is 24, 2 times 0 is 2, 24 plus what number up here gives me 238, and the answer is 214. And 6 times 2 is 12, and 2 times negative 1 is negative 2, and 12 plus negative 2 is 10. So 10 plus what number gives you 92, and the answer is 82. And I look up element 82, and it's lead. So this is, in summary, 6 alphas and 2 beta decays. Here's another one for you to play around with if you'd like to, but I'll just leave it for you to struggle with, try it, ask questions. Here's a simple one. Which of these is an alpha particle decay? Let's see, alpha has a 2 down below and a 4 up above. So 31 plus 2 is not 30. 28 plus 2 is not 29. 85 plus 2 is 87. So it could be this one. Let's check it. 208 plus 4 gives 212. This is a 4 and a 2 and an alpha. The others are probably not. 52 plus 2 is not 51. Looks like this is a negative 1 and a 0. That'd be a beta decay, right? Alpha. Do you have the hang of this yet? I'm going to leave that one alone. You can look at it if you want to. Neptunium-237 decays into protactinium-233. What kind of change is this? I have no idea. Let me write that down. 237 neptunium, protactinium-233. 233 plus what number gives you 237? Wouldn't it be 4? And 91 plus what number gives you 93? 2? 2 and 4. Oh yeah. That's a alpha decay, isn't it? What's the product of the beta decay of bismuth-214? Beta, bismuth-214. Let me write that down. Here's bismuth-214. Bismuth is element 83. The beta decay is the electron, so that's a negative 1 here, 0 here. Negative 1 plus what number gives you 83? Wouldn't it be 82? 0 plus what number gives you 214? Duh, 214. So wouldn't it be something like that? I think, and yeah, it's looking pretty good. So bismuth actually changes into polonium. But again, in chemistry we define these elements to work with them by the number of protons, and they have different chemical properties. But the nuclear changes are, of course, radically different. If we're changing the nucleus, if we're changing the number of protons, and by definition we change the kind of element we're talking about. Let's see, where am I at? I might just leave some of these for you to fiddle with. Here's uranium alpha decay into what? Neon 24 beta decay into what? Nitrogen positron emission to what? 1 plus 6 is 7, 13 plus 0 is 1. That's the evil twin, the antimatter particle of the electron. Here's the electron capture of beryllium-7 into lithium-7. So 0 plus 7 in the upstairs, 4 minus 1, and 3 is 3 in the downstairs. I'm tired of talking. It's Friday afternoon. I'm going to go home and have a refreshing beverage and maybe a nap, or maybe a nap and then a refreshing beverage. In any case, thanks for watching, guys. Thanks for practicing. You might possibly see one or two of these equations on the final exam. It's not uncommon to see these on standardized tests, just to see if you can balance 98 plus 0 and 6 plus what, and 244 plus 6. 6 times 1 is 6, and that equals 12 plus what. Alright, thanks. Like I said, I'm shutting up.